Alright, we are looking at multi-step equations. So multi-step meaning that there's just more than two steps. So you've already seen one-step and two-step equations. Now we're looking at multi-step. So the first thing that we want to do is distribute when we have a multi-step equation. After we distribute, we want to simplify a little bit, so we are going to combine like terms. So we are simplifying, we're combining like terms. We are not crossing the equal sign, so we're not actually doing any solving quite yet. We're just trying to clean up our equation a little bit. So what's left, we should have an equation, and most likely it will look like a two-step equation, and we just want to go ahead and solve. So let's look at some examples so far. Alright, so here's our first example. The first thing I want to see is if I have anything to distribute. I do not, so I'm going to go ahead and combine like terms. So I have 8x minus 3x, and if I combine these, we get 5x. Bring everything else down, and here we have a two-step equation. So the first thing I want to get rid of is the subtraction, so I'm going to add 10 to both sides. Addition cancels with the subtraction. We are left with 5x is equal to 30. And I see multiplication with my x, so I'm going to divide by 5, and we are going to get x is equal to 6. Now trying to get a habit of checking your answers. So I'm going to go back to my original equation, and I'm just going to substitute in 6 for x. And now we're not solving anymore, we're simply simplifying, so I'm going to use PEMDAS here. So multiplication is what I see first. So I have 48 minus 18, and this should be minus 10 up here, so minus 10 is equal to 20. And if I do all the subtraction, we do indeed get that 20 is equal to 20, so it checks out. We did solve our multi-step equation correctly. Second one, again, I don't see any distributive properties, so I am going to combine like terms. My like terms being 9d and negative 2d. When I combine these, we get 7d, bring down the plus 4, equals 32. Again, I want to get rid of the addition. I want to subtract 4 from both sides of my equal sign. The subtraction will cancel with the addition. We are left with 7d is equal to 28. Again, I see multiplication, so I'm going to divide, and we will end up with d is equal to 4. Again, it's pretty easy to check, so I'm going to go back to my original equation, and every time I see the letter d, I am going to plug in 4. Again, we're no longer solving, we are simplifying, so first comes multiplication. And then we are going to add and subtract. So 36 plus 4 gives me 40, minus 8 gives me 32. So again, this does check out. Third one, first up is this distributive property. So I'm going to first multiply 3 in w, which gives me 3w, and then I'm going to multiply 3 times 4. So this is a positive 12. So after I distribute, I have 3w plus 12. I need to bring down everything else. Addition signs, equals, equal signs, and numbers. Again, I need to check to see if I have any like terms, and I do. I have 2w and 3w. So these combine to give us 5w. Plus 12 is equal to 27. I want to get rid of the addition, so I'm going to subtract 12 from both sides. What we are left with is 5w is equal to 15. I'm going to divide both sides by 5 because I see multiplication. And we get w is equal to 3. Again, a quick check, so going back to the original problem, the original equation, I'm going to plug in 3 for w. And once again, we are using PEMDAS, we're using order of operations. So first comes parentheses, I'm going to add. 3 is being multiplied, 2 times 3 gets brought down, equals 27. Now I have multiplication. 6 plus 21 is equal to 27, and 27 is equal to 27. We have a correct answer. Moving right along to example 4, again I see distributive property, so I'm going to distribute negative 2 times x, which just gives us negative 2x. And then I have negative 2 times negative 5, so a negative times a negative gives us a positive. 2 times 5 gives us 10. Everything else just need to bring down. Again, looking for like terms, I have 6x and negative 2x. These combine to give us 4x. And bring down plus 10 equals 46. Again, I see addition that I want to get rid of, so I'm going to subtract 10 from both sides of my equal sign. We are left with 4x is equal to 36. And once again, I see multiplication, so I'm going to divide. And I will get x is equal to 9. Again, quickly check, so 6 times 9 minus 2 times the quantity 9 minus 5 is equal to 46. Parentheses comes first because, again, I am simplifying. I'm using order of operations. Rewrite everything down, so 6 times 9. And now comes multiplication, so 6 times 9 gives me 54. Negative 2 times 4 gives me minus 8. And equals 46. And when I subtract, I do get 46 is equal to 46. Last problem, and don't let the fraction throw you. So the first thing I need to do is distribute. Now if you remember your fractions, when I multiply fractions, I'm going to multiply numerator times numerator. So 3 times 3x gives me 9x. 2 times the one that I put underneath the 3x to make it a fraction, so 9x over 2. I also need to distribute it to the 5, so I have a positive times a positive. 3 times 5 gives me 15. 2 times 1 again gives me 2. Bring down the equals, and then minus 24. So there's 2 ways we could do this. The first is, well, actually, I need to subtract this 15 halves first. And again, I see addition, so I am subtracting. Doesn't matter that this number is a fraction. Now I want to get to this subtraction, so I can do it by hand. So negative 24 minus 15 halves. Now if you remember your fractions again, when I'm subtracting, I need a common denominator. So right now this is negative 24 over 1. I wanted to have a common denominator of 2, so I'm going to multiply the top and bottom by 2 and get negative 48 over 2 minus 15 halves. From here, I'm going to subtract the numerators. So negative 48 minus 15 gives me negative 63. Keep the denominator the same. So let's go back to our equation and put that in. Now the other way of doing this, we do have calculators. So I had negative 24 and I was subtracting off the fraction 15 halves. So hopefully this will confirm that yes, we are using the fraction negative 63 over 2. From here, I want to use the reciprocal, multiply it on both sides of my equation. So I'm going to multiply by 2 over 9. And this will cancel out. We're left with x is equal to, and we can divide on or simplify on the diagonal. 9 goes into both 9 and negative 63, so this is negative 7, this is a 1. And I can also simplify on the other diagonal. 2 goes into both of these, so we do have negative 7 here. Or again, we can go back to our calculator, and we are taking negative 63 and we are multiplying it by 2 over 9. Let me use a fraction. So 2 over 9. Get rid of this. And hopefully we do get negative 7. The other way of checking using your calculator, and I just want to mention this, so I do have a way to tell my calculator what I want x to be. So if I want negative 7, I can hit this store button, which is the button right above the on button, and I want to store it for x. So now every time I use x, my calculator knows that I want -7. So going back to our original equation, we had 3 halves. So 3 halves, then we had a parenthesis, then we had 3x, so I'm going to type in exactly 3x plus 5, and the calculator is going to do all the order of operations for me. So it does look like our answer checks out. We should get -24 when we plug in, and we do. Alright, example 6. We have a math class taking a quiz. Jonah has a z-score of -2. So I can start making a list. So z is equal to -2. If the standard deviation is 14, so we have this symbol, and the mean is 72, we want to know what their score on the test was. So we are actually looking for what x is. And we do have a formula for z-score. We have this formula here, x minus mu, the mean, all over the standard deviation. Now we have numbers that we can plug in. Z we know is -2. X is something we don't know. That's what we're solving for. Mean is 72. And over a standard deviation of 14. Now this is going back to 2 steps of equations. So the very first thing I want to do is I see division. So I'm going to multiply both sides by 14. What we end up getting is -28 equal to x minus 72, and we want to add 72 to both sides. So 72 minus 28 gives us 44. So this particular student, Jonah, he got a 44 on his quiz. Alright, moving to the back of the notes, we are going back to our statistics. So we have scores from a statistics class. I'm going to put this list into my calculator, so I'm going to hit Stat and Edit. I'm going to type out all these numbers, so 155, and so on. Should be 71. Alright, so 155, 82, 77. Looks like I got a mistake there. So let's fix that. 93, 71, 69, 88, and 80. So again, hit Stat. I want to go over to calculate one variable statistics. Hit Enter a bunch of times. And we are looking for the mean and the standard deviation. So it looks like the mean is about 79. The standard deviation we can round to 13. So 79 for our mean, 13 for our standard deviation. The next thing that we want to look at is the normal distribution. So if you remember that, we actually have that bell curve. So let me draw a number line. And let me try to draw a nice bell curve. Again, if you remember, right in the middle of our bell curve is our mean. So that is the 79 that we were talking about. To the right, I'm adding one standard deviation away. So I'm going to take the 79 and I'm going to add the 13 to get to our next mark on our normal distribution. So 92. Again, if I add another standard deviation, we're at 105, and if we are 3 standard deviations away, we add 13 again to get 118. Now we also need to go in the opposite direction, so I need to go back to my mean and subtract off 13. So 79 minus 13 gives me 66. I go another standard deviation away, I go another 13 away to 53, and I go one last standard deviation away, subtract off 13 again to get 40. we want to get the z-score, so it looks like I'm missing a little something on my last slide. We want to get the z-score for a test score of 88. So that's going to be your x. Again, we are using our z-score formula, x being 88, minus our mean, which was 79, divided by our standard deviation, which was 13. So I could go to my calculator, or I need to do the subtraction first. In this case, we are going to get, I believe, 9 over 13, which is equal to about 0.7. So for letter B, we should have an answer of 0.7. He has a z-score, so he's slightly above average. I know that because it's a positive z-score. Now getting to part C, we want to know what the test score is when we have certain numbers for z-scores. So we are again looking for x. We want to know what that data element is. So for the very first one, our z-score is negative 1.5. We're looking for what x is. We still know our mean is 79, and our standard deviation is still 13. Again, this is your two-step equation. I want to get rid of the division first, so I'm going to multiply both sides by 13. That should make us have negative 19.5 is equal to x minus 79. Go ahead and add 79 to both sides. And we get x is equal to 59.5. So hopefully this makes sense. So if I go back to my normal distribution, if I go about 1.5 standard deviations away, I should be somewhere in between 53 and 66, and I am. Moving on to a z-score of 1.3, again that's z is equal to x, which we don't know, our mean 79, our standard deviation of 13. Again, multiplying both sides by 13, and then I'm going to add 79 to both. We should get 95.9. When we have a z-score of 2.5, x minus 79 over 13. And I'll leave it like that so you can go ahead and solve. And the last one, I'll set it up for you. So negative 0.05 is equal to some data element we don't know, minus 79 over 13. So for all of these, the process is pretty similar. I'm starting by multiplying both sides by 13, and then I add 79. So for number 3, we should have 136.5, and for 4, 78.35.